Today we're going to be talking about the concept of similar triangles. We're going to start with a postulate, postulate 7.1. It's called the angle-angle similarity. It says if you have some angle A congruent to some angle F, and some angle in a triangle B congruent to some angle G in a different triangle, then the triangles will be similar. Notice it doesn't say congruent, it says similar. So let's look at an example. If we have triangle LJK, we have angle L is 57, and QPM, angle M is 57. So we know two angles in our triangle. What we can do is we can figure out this missing side K. The way we do that is we say, okay, well, in a triangle, they always have to add up to 180 degrees. So I do 180 minus 57 minus 48, and that equals 75 degrees. Okay? So if I know that this side right here is 75 degrees, angle K is 75, angle P is also 75. So that means that our triangles have two congruent angles, which means they're going to be similar. Now, we need to write our similarity statement, and we have to do it correctly so that they correspond with the correct angle. So I'm going to write it like this. Triangle L is 57, K is 75, J is 48. Is similar to triangle. Well, I did my 57 degree angle first, so that would be M. Then I did my 75, P, and then finally Q. So those are similar. Alright, let's look at example B. In example B, I know for sure angle S is congruent to angle S. Why? Those are vertical angles, means they're going to be equal. Now, the other important information is that these two lines are parallel. So remember, when you have parallel lines, this angle right here, angle R, is going to be congruent to angle W because they are alternating interior angles. And the same would actually be true for X and T. Those are also alternating interior angles. So I see that all three angles in my triangles are going to be congruent, which means that for sure, even if we only had two of them, we could know that these are going to be similar triangles. So I have to write them correctly. So I'm going to start with angle S, then R, then X, so black, red, blue, is similar to, same thing, black, red, blue. So that'd be S, W, T. And we have to label it correctly, otherwise it doesn't prove a similarity statement. Here's a couple examples. You can try the same now. So we're left with a couple theorems. They're called triangle similarities. And just like back when we had like the side-side-side theorem, this is a side-side-side similarity, which means that instead of them being congruent to each other, it says that if they're proportional to each other, then the triangles are similar. Theorem 7.3 says the side angle side theorem. It says if the two sides, so SRYX and STYZ are proportional and my angles have to be the same, that proves that my triangles are similar. Let's see these in an example. It says determine whether the triangles are similar. If so, write a similarity statement and explain your reason. So if I look right here, okay, I'm looking at my two triangles. Just like in example 1, we know that angle R is going to be congruent, both of them, because it is vertical. Then we can say, okay, then RP would have to be proportional to RS. So I'm going to write out my proportion. And I'm going to say RP, which is 8, over RS, which is 20, should be proportional then to RQ and RT. So let's write that. So that'd be 5 over 12.5. Okay? So how do we check to make sure that they are proportional? Well, it's a proportion, so we're going to cross multiply. 8 times 12.5 is 100, and 20 times 5 is 100. So we see that these two sides, the purple and the blue, are going to be proportional to each other. That's good. Now, I also have to make sure, though, that PQ is proportional to ST. So I start with my original proportion, 8 over 20, and I see if it's equal to 6 over 15. Cross multiply. 8 times 15 is 120. 6 times 20 is 120. So they all check out. So are these triangles similar? They are. So I could write the similarity statement as triangle RPQ is similar to triangle RST. Very good. All right, let's look at example B. Now, example B is kind of unique in the fact that angle A is both in my smaller triangle and it's in my bigger triangle. So for sure we know that the angles are going to be congruent because it's the same angle. So the reflexive property would say that they're the same. Now what we have to see is if this side right here, AE over AC, is proportional to AF over AB. Okay, so we're going to write it, I'll write it out this time. AE over AC should be proportional to AF over AB. So let's plug in our numbers that we have. Okay, well AE is 8, and AC then, the whole thing is 8 plus 4, which would be 12. We want to see if it's congruent, or excuse me, proportional to AF, which is 10, over AB, which is 15. How do I check to see if they're proportional? I cross multiply. 8 times 15 is 120. 12 times 10 is 120. So they are proportional. So how would I write my similarity statement? It's going to go like this. I'm going to say triangle AEF is similar to triangle ACB. There's a couple guided practice problems for you to try as well. If we know that in this example that ADB is a right angle, which of the following would not be sufficient to prove that the triangles are similar? Well, if I look at the first one, option A, it says that AD over BD could be proportional to BD over CD. Okay? So that would actually help us out because you'll see that if you're looking at the triangles separately, it looks like those would be the corresponding sides. So angle A could help us out. Let's look at option B. Okay, I'll get rid of my drawings there. Option B says AB over BC to see if it's proportional to BD over CD. Now you'll see that those are not the corresponding sides in my triangle. So it wouldn't help us out there to figure that out. So option B will not help us out. So which one's not sufficient? Option B is not sufficient to figure out if those triangles are similar or not. Okay, so just like we had properties of congruence, we also have properties of similarity. There's the reflexive property. A triangle is always similar to itself. We have the symmetric property. If ABC is similar to DEF, and DEF has to be similar to ABC. Then we have the transitive property. If ABC is similar to DEF, DEF is similar to XYZ, then obviously ABC is going to be similar to XYZ. Okay, all those properties we've seen before. So let's look right here at example 4. Example 4 says they want us to find BE. Okay, well, the similar triangles, you'll see that angle C is the same in both this triangle, and it's going to be the same as angle B right here because those are parallel lines. So we can see this triangle right here, okay, and then we have the big triangle right here. So let's set up our proportion. Well, I'm going to set it up like this. I'm going to say 3 over the whole thing of 5 has to be proportional to x over 3.5. How do you solve a proportion? You cross multiply. 3 times 3.5 is 10.5 equals 5x divided by 5. You find that BE, I called it x, but let's call it BE now. BE is going to have a length of 2.1. Okay? Now the next thing is to find AD. Well, if I want to find the whole thing AD, I'm going to first have to set up my proportion and say AE over AD. So I'll use the same proportion 3 over 5 that I used before, because that still holds true. 3 over 5 is going to be equal to AE, which is y, over AD, which is y plus 3. And now it's a proportion problem. I cross multiply. 3 times y is 3y plus 3 times 3 is 9. And that's going to be equal to 5y. Moron problem. I subtract 3y from both sides because there's more y's on the right. I get 9 is equal to 2y. Divide by 2. Divide by 2. Y is going to be 4.5. But that's not what they wanted us to find. They wanted us to find AD, which is 4.5 plus 3. So AD is going to equal 7.5. Here's a couple guided practice problems. You can try the same as well. Alright, last problem. Indirect measurement. Haley is estimating that the height of the Superman roller coaster in Mitchville, Maryland. She is 5 feet 3 inches tall and her shadow is 3 feet long. If the length of the shadow of the roller coaster is 40 feet, how tall is the roller coaster? Okay, so the nice thing is we have the sketch already drawn for us. Okay, we see that there's this little triangle here created where Haley is going to be 5.2 feet and her shadow is 3 feet. So let's write the proportion, 5.25 feet, her height over the length of her shadow. And it's going to be equal to, and you'll see that the shadow of the roller coaster is 40 feet, but we don't know the height of the roller coaster. And so now it's an easy proportion problem. We cross multiply. 3 times x is 3x. 5.25 times 40 is going to be 210. How do we get x? Divide by 3, divide by 3. So the height of the roller coaster is going to be 70 feet. Here's the final guided practice problem. Sketch the picture, the similar triangles, and solve from here.